Okay, so similar to the last section where we were dealing with a sphere that we are drilling a hole out of, this time we're taking a right circular cylinder. Right, so we want to find the volume of the solid form when we take and drill a 3-inch radius hole symmetrically, so right through the center along the axis of a 6-inch right circular cone. Okay, a 6-inch right circular cone with a height of 9 inches. So right circular cone is just a cone, just standard cone. So we have a circle here with a radius of 6. Right, and we're forming a cone. From that, draw properly. Right, so forming this cone, get to draw itself properly. There we are. And we know that this cone has a height of 9 inches. Okay. And what we're going to do is we're going to drill a hole through this cone. We're going to drill a hole through this cone, and that hole is going to come straight down through. Right, and that's what we're going to do. So that's our cone. So the first thing we have to figure out before we can deal with drilling a hole through the cone, what we want to first do is figure out, well, how would we generate a cone? How would we generate a cone? Well, to generate a cone, we simply take a straight line starting at the origin that deals with this dimension, 6 and 9. So at the origin, that's the bottom of the cone, and then it comes out to this point up here, 6, 9. So on the x-axis, we're out here at 6. The y-axis, we're out here at 9. All right, so that's what we're going to do is take that thing and revolve it about the axis, the y-axis, the way I've drawn the picture anyway. So that way you have your radius 6 here, right, and that's going to produce your cone. So we need to find out the equation of this line here. Well, it has 0, 0 as a point, and it has the point 6, 9. So that means the slope of this line would be 9 over 6, or 3/2, and it passes through the origin, so the equation would just simply be y equals 3/2 x. Right, that's going to be our equation for our cone. And again, we are revolving this thing about the y-axis the way that I have this set up. Okay. The final thing we're doing is we're passing a 3-inch radius hole. So if I mark on my axis here, x equals 3, we're drilling a 3-inch radius hole through the cone. Well, that hole is just going to basically be a cylinder. So if you take this 3 and let it go right straight up through, we would have this point. We would have this point, the 3 going up through. Okay? And so now we just need to look at what we have here now. So basically, we're taking the difference. Now, this region here is basically all that's going to be left. because you can see it in the picture here, part of that, any part of the cone where the radius is less than 3 inches is gone. So that's kind of at this key point right here. And now we want to find the volume. Now we could do this with washers. We would have to measure like so. Okay. Or we can do it with shells, which is actually the way I want to do it because that's what this section's about. So for shells, we would measure our axes, our rectangle parallel to the axis. So we would be measuring the height like this. And since we're doing shells and we're revolving about the y, we're going to be integrating with respect to x. And so for the x, we're going to be looking here at the integral that starts at x equals 3 and continues to x equals 6. Okay, and so we're ready to go to compute our volume now. So volume is going to be 2 pi integral from 3 to 6 of x times the height of our section, which is going to be 9 minus 3/2 x. dx. And here I'm going to do a little bit of cleaning. Because I have that fraction, I want it to disappear. I'm going to take the 2 from outside and multiply through along with my x. So 2 and 9 will be 18x. 2 cancels with the 3/2 to leave me with a 3. So I have minus 3x squared dx. And then we just do our integral. Pi integral of 18x will be 9x squared. Integral of 3x squared will just be x cubed, evaluated between my endpoints of 3 and 6. Okay, and so when you do this, you should get, unless my arithmetic computation is wrong, 54 pi. You should get 54 pi when you compute this. So plugging in 6, and then computing that, and then plugging in 3, and taking the difference, you should then get 54